right, so this is number 6. We are solving a 3-system variable by substitution. Now, number 5 in the notes, which I have over here, was set up for substitution. I mean, it was the perfect problem for solving in that method as opposed to using elimination. Number 6 is set up to where you really could choose elimination or substitution. But because I'm trying to teach you the substitution method, that's how we're going to solve this one. So to start, we need to solve for a variable in one of the equations. So I'm just going to solve this first equation, equation 1, for x, just because x has a coefficient of 1, so it makes it easy. I just need to move the y and the z to the other side by adding or subtracting, whichever cancels them out on that left side. So I am going to have x equals, I'm going to subtract the y's from both sides so it moves it to the right side of my equation. I'm going to add the z to both sides so it moves it to the right side of the equation. And on the right side, I still have that positive 4, so it's a plus 4. So now I have solved for x. All of this equals x. So in my equation number 2, I'm going to substitute that in for x. So I rewrite equation 2, but instead of x, I'm going to write all of that, the negative y plus z plus 4. And then I write the rest of equation 2, so plus 2y plus 4z equals 17. And I can simplify this quite a bit. I first have to get rid of the parentheses by distributing the 3 to all 3 terms inside. So I get negative 3y plus 3z plus 12. And I will say that constant is where people miss it the most. So make sure you're multiplying by all 3 terms inside the parentheses. And then the rest of the equation stayed the same. So plus 2y plus 4z equals 17. All right, so my left side has just a lot of terms. So let's collect some like terms and simplify this down a little bit. So I have y is right there. So I have a negative 3 and a positive 2. So that adds up to a negative y. I have 3z and 4z. So that adds up to 7z. And I still have that plus 12 right here. So and all of this still equals 17. So that's a lot cleaner. Let's get all the constants to the right, because that's how we're used to seeing the equations when we're doing elimination and substitution, all that. So let's subtract 12 to both sides. And I get 5. Okay? So this is simplified. And I'm going to number this just so, because that's what I do. So if this is equation 3 up here, let's get another color going on here. It's hard to choose. Okay. So we're going to call this equation 4. You don't have to number them. I do that so when I'm talking about them, it's easier for you to see since I can't point and you see on this. All right. So I've dealt with equation 2. I'm down to 2 variables. So let's get equation 3 down to 2 variables so we can either do elimination to finish it off or we'll see what happens, or we can do some more substitution. So if I do equation 3, whoa, sorry about that, it just jumped. Equation 3, I'm going to substitute all of this in for x. So it's negative, and then I write whatever, all that stuff for x, the negative y plus z plus 4. And then I write the rest of equation 3. So plus 5y plus z is going to equal 8. Just like in equation 2, I don't know, I keep pushing buttons, I'm sorry. I got to distribute the negative, so I end up with a positive y minus z minus 4, and then plus 5y plus z equals 8 stayed there. Let's collect those like terms and clean this up. I have y there, I have a 5y here, so that's 6y. I have a negative z and a positive z, so that's 0. My z's just went away. That's very convenient. I still have a minus 4 over here, and then on the right side I have an 8. Add 4 to both sides. Divide by 6 to both sides. So I got y already. So if I'm going to start my final answer here as my x, comma, y, comma, z, the y is in the middle, so I have the y. And let's start solving for z and x. So I have done something with each equation here. I solved for x in equation 1. I substituted in for equation 2 and got that. I substituted into equation 3 and got this. So I've dealt with all 3 equations. So now I'm going to use these things that I found and get the rest of my final answer. So I'm going to take y being 2, and I'm going to substitute it into equation 4. So if y is 2, so I have negative y, so negative 2 plus 7z equals 5. So now I can solve this for z. So I'm just getting rid of the parentheses here. So I need to add 2 to both sides and divide by 7 to both sides. Whoops, z equals 1. All right, so I have the z part of my final answer. Now we're going to take all of that. We have a z, we have a y. We're going to take both of these and plug them in for x. So I have x equals negative whatever y is plus whatever z is plus 4. So it's negative 2 plus 1 plus 4. Add that all up. I get negative 1 plus 3. Or plus 4 is 3. So, this was x equals. So, in my final answer, I have that x is 3. Here's my answer. So, I have one solution for this system. And to check it, if I make some room over here, you plug them in for the original equation. So I have 3 plus 2 minus 1. Add that up and subtract by 1. You get 4. Okay. Plug it in for these x and y's. Plug it all into your calculator if you need, but you should get 17 for that one. And then you plug it into this one, and you should get 8. Because I've already done all that, I know that this is my final solution. So in numbers 5 and 6 in the notes, we've now covered getting one solution. So move on to problem number 7, and we're going to see how it looks when we get no solution using substitution.